Hello everyone. Thank you for being here. My name is Sarthak Vakre, and I am a software developer too at Geeky Ants. So, the topic for my talk is on device intelligence, building turbo modules with TensorFlow. First of all, I'd like to talk about AI and its significance in mobile. AI in mobile has been there for many years now, and the main trend that is being applied in mobile applications is that AI is basically focused on very specific problems and very smaller problems in general. So the AI models that are generally used are trained on relatively smaller data sets, and they solve a very specific problem. And let's take a look at some examples. So, so the first example that I want to share is basically how the images are handled on a device and how AI is used in overall flow of images. So it all starts with the camera. This example, I'm pretty sure everyone has experienced. So in camera, we can see things like object detection right away in the viewfinder when the camera basically recognizes people and other objects. And after that, when we click the image, we go through a layer of post processing, and the image basically goes through another AI model. And in this step, it improves the things like color, like skin tone and colors and blur. And it does not stop there. After we click the image, it goes to the gallery, and it again goes through a layer of AI where an image classification model is run, and the image is basically categorized into something, so that in your gallery you can see your images categorized by various things. And some of the devices, for example, on Android, also support editing features like Magic Editor, where you can highlight the subjects, remove them, or add background, and do a few more things. In this example, it basically shows how these small things are like in small independent things are integrated with AI, and how they help us in day-to-day life. So how do we do this in React Native? How do we implement AI? So first of all, like going outside React Native, the first option is cloud services. Everyone has probably used OpenAI and Gemini AI services, and the main advantage of these services is that they are easy to implement and get started. You can use their API to implement features in your app, and if you are prototyping or are on a short deadline, then these can be very helpful. But they come with their own disadvantages, like the extra cost or subscription. And also there is a network delay which can be annoying for complex tasks, for example, something related to images or videos. And it completely takes away the option for offline capability. And the last thing is that privacy is out of your hands, since these services are located on external server. What's the counterpart? The other part is we can run these models on your device, and like there are many ways to run. You can also run this model on the JavaScript thread itself, and do not deal with the native side completely. But in the scope of this talk, I'll cover the other side, which is running the models via turbo modules natively. What are the pros and cons of of this method? So, the obvious ones are that the network delay is eliminated, and we have complete privacy over our data. And also, there are no limits on the usage, which I think improves the user experience by a lot. And the most important thing is performance. Uh, since we are running natively, the performance is way better than the other option, and we'll see in the next slides how the performance is maintained. But first of all, let's I want to cover the the disadvantage, which is the complexity of implementation. Since we are dealing with implementing LLMs on both implementing AI on both platforms, there it comes with a implementation cost, and that can be very complex to implement. So hopefully by the end of this talk, some of that complexity is resolved. Now coming back to performance, there are two important pillars of performance by this method. So the first one is JSI. In the new architecture of React Native, JSI was introduced, and it basically allows us to directly invoke the native functions from JavaScript, and it also uses the C++ shared memory to facilitate data sharing. Now this this actually improves the performance by a lot because it eliminates the old way where we needed serialization, batching, and deserialization of data. The second is background threads. So since we are running this on the native side, we have the freedom to run the process on a background thread, which will not block the UI thread and improve the user experience and the performance. All right. Since we have got the basics out of the way, I'll talk about two things, which are turbo modules and TensorFlow, and then we'll get into the implementation. So turbo modules are turbo modules were also introduced with the new architecture with JSI, as I talked earlier. And these have some perks over the previous implementation, which were native modules, like they have fast execution and lazy loading, which provides better performance overall. And to write turbo modules, we have two options. So we can write the native code for each platform, or we can write C++ code, which is actually cross-platform. So in the scope of this talk, I'll cover the first method, which is writing native code for both platforms. The next thing I want to discuss is TensorFlow Lite. So TensorFlow Lite is a great package which brings ML to mobile. It provides various models which you can get on TensorFlow, Model Zoo, or Kaggle. And these models basically have the extension of .tf Lite, and we'll be dealing with those models in this process. So these are very small models, and they are optimized for mobile specifically, and these are also built to work with your device hardware. So the main thing is the TF Lite model can be new to someone getting started. So what's inside the TF Lite model? How do you inspect it? So there is a tool called Netron, which is an open source model visualization tools. And in that we can basically open our model, and it will show all the various parameters like input and output and other metadata for that model. And what we are concerned with is the input and output parameters. So before we implement the actual code, we need to make sure that the input and output is uh, proper as per our needs. So let's take an example of an object detection model. So for example, if you upload that model, it will show that the input parameters required by the model are shown like the array mentioned here. So this array basically specifies that this model takes in a single image, and the image should be of 448 into 448 dimensions, and it should be of RGB channel. And it also gives us other information like the output metadata. For example, the object detection model will output the location, scores, and the categories of the detected boxes, and we can use that information however we want. Okay, so with the basics of this two things out of the way, we can take a look at how to implement this. So before I start, I like to mention that the code for this is actually fairly large. So I will go through the pseudo code, and each step will be the basically the gist of the implementation and not the full implementation. But the full implementation is available on my GitHub, which is added as a QR code at the last slide. So the first step is to create a CodeGen config. So CodeGen is a tool which basically generates the glue code so that we can call our native modules. And to do that, we first need to create a specification which is just a TypeScript file. Uh, let's just call it TensorFlow native TensorFlow module.ts. And in that file, we need to specify our specification. So this will just be a TypeScript interface which will have the function that we want to call. And in this example, the function is called run inference, which the implementation for this function will be in the native code, which we will discuss later. But to define the interface, this run inference function will take in two parameters like model path and the image, which will be in base64 format, and it will return the string as a promise. So the string will be basically the category, uh, the classified category that the image classifier will output. Uh, in the next step, we need to update our package.json, where we will add some configuration for the CodeGen. And keep in mind that the name should be the same as it was in the specification. So here we'll add some Android and iOS specific specification like the package names. And after this is added, we can go into Android folder and we can run this command to basically generate the glue code. And similarly, we have the bundle install command for iOS. After this step, we are getting into the native step, like the step in which we write the native code. So let's start with Android. And this is an example of how the folder structure looks like for Android. So basically, what we want to do is we have to create a new module which exists beside our main app module. So in our case, like we defined in the package.json, our module is called native TensorFlow. So we'll create that folder and we'll add these two files. One is the module.kt and second is the package.kt. So we'll start with the Kotlin implementation for the native TensorFlow module. And in this file, we basically there is a lot of boilerplate in that file. So if you are writing some other implementation, a lot of these things will be the same. Only the function that we are triggering will be different. So keep in mind that we are creating a class and we are calling the same function that we defined in our specifications. So you can see in this file we have a name parameter. So this is very important, and the name of this class should be same as it was defined in the specification. And finally, we have our run inference function. So this is a huge implementation, but what this basically does is it loads the TensorFlow interpreter and the model. And if you remember, we talked about Netron and how to inspect the input and output of the model. So what we'll do is we'll take the image that is passed to this function and we'll convert it in the format that is supported for the model, and we'll then run the interpreter using TF-Lite. Finally, the model will spit out the output, and we'll use that output and return it back to the JavaScript by resolving the promise. Uh, and so this was the model file, and then next we have to update the package file. So here we just have to initialize our module that we just created, and keep in mind that in the last line Ace Turbo module should be true. And that's it. We just add our package to the main application.kt, and our Android native code should now be able to build. Next, if you're targeting iOS, a very similar implementation has to be done. Just the steps are a little bit different. We'll open our app in Xcode and create a group called native TensorFlow, and then we'll create uh, and then we create a new file which will be of Cocoa Touch class, and we'll select Objective-C as a language. So initially, the file that will be created will look like this in this example, and we have to make sure that the main file should be of the extension .mm and not .m, which will convert it into an Objective-C plus language. So this is Objective-C++ implementation for iOS side. This is very similar to what we saw in Kotlin. For example, we have a module name function which returns the name of the module, and the run inference function which basically does the main job. The implementation will be very similar like we had before. And similarly, we'll in the native TensorFlow.h file, we'll basically initialize the specification, and that's it. We should be able to build our iOS app now. Uh, and as the final step, since both our native codes are built, all we have to do is import the specification that we defined earlier in the first step, and we can just directly call the run inference function like this. And that's all we have to do to run native code. So as a result, you will have this application where you can select the images and it will show you the results. So in this particular model, it shows the name of the classification and the confidence that it has on that result. So that's it. Thank you for attending this. And if you are interested in the full code, you can scan this QR code and take a look at the actual implementation. Or if you have any questions, you can ask me on my socials. Thank you.